Hello everyone, my name is Amrita Bhatnag. I am from CSE department of AKGEC. Today I am going to explain a very good topic from the unit 4, cache mapping technique, which is very important topic. So firstly we should understand what is the use of cache in our system, then we will understand what are mapping techniques. So these are all the outlines of the lecture. Firstly we will understand cache and concept of cache, then what is the meaning of cache mapping technique, then we will understand different mapping techniques. First one is your associative mapping, second one is direct mapping, and third one is the set associative mapping. So firstly we should understand what is the use of cache memory in our system. So cache memory is a small high speed memory unit that stores frequently used data and instructions for quick access by the computer's central processing unit. It is act as a buffer between the CPU and the main memory RAM, and it's crucial component of modern computer system. So you can see here, this is the diagram for the cache memory. So what happens when the CPU is executing a particular program, there is a we have very slow memory, main memory. That's why there is a delay in the execution of a program. So because the speed of the CPU is very high and speed of the main memory is very less, so we have a small size memory which is known as a cache memory, where we will put all the data which is very mostly recently accessed. Okay, so we will kept all the data which is recently executed in the cache memory. So that what happened with this arrangement, then the speed of our program execution will be increased. Fine. So this is the use of cache memory. The size of the cache memory will be smaller than the main memory. So we can keep less data in the cache memory, and the speed will be the high from the main memory, because less data, so less time is required to access the memory. So when the data is accessed in the cache memory, or we can find out the data in the cache memory, then it is known as a process of hit. If the data is not found in the cache memory, then this is known as a miss. So when CPU execute a particular program, when it requires a data, it will find out the data from the cache memory. If it is available in the cache memory, then it is known as a hit, and if it is not found in the cache memory, then it is known as a miss operation. So in the case of miss operation, then it will access the main memory, and then that data will be kept in the cache memory. But this will take 2 memory cycles. For example, firstly CPU will find out the data into the cache memory, and then CPU find out the data from the main memory. So it will take more time. So we should reduce the number of miss in our cache memory. If the number of hits are more, then cache memory performance will be better or efficient. Now the concept of introduction to mapping. Cache mapping refers to a technique using which content present in the main memory is brought into the memory of the cache. Okay, what is the meaning of mapping scheme? Actually, when the CPU find out the data into the cache, but CPU will generate always the address of the main memory. But now the data is in the cache, and we are looking the data into the cache. So we have to find out the address of the particular data into the cache memory also. So we have to convert the address of the CPU, which is the address of the main memory. The CPU will generate the address of the main memory, and we have to convert this address into the cache memory address. So this is known as a mapping scheme. So we have 3 types of mapping scheme here: associative mapping, direct mapping, and set associative mapping. Okay, so these all techniques are its advantages and disadvantages also there. So firstly we will start with the associative mapping. Associative mapping uses associative memory. So what is the meaning of associative memory? Associative memory is a memory which work on the matching logic. So match logic is requires some hardware, and we need more hardware in this associative memory. But in this case we don't have addresses like a RAM. in this case we match the word by the matching logic. Fine. This is memory being accessed using its content. So it is also known as this memory is accessed by the content only, not by the address. Each line of the cache memory will accumulate the address main memory and the content of the address from the main memory. That's why this memory is known as a content addressable memory. So the name of this is the another name of the associative memory, content addressable memory, because this memory can be accessed by the content only. Now you can see here, this is the figure for the associative memory. So this is the cache memory. Okay. Now for example, we have a main memory also here, and the size of the memory can be 256 into 12. What it means? It means main memory have 256 words, store words. The number of store words are 256, and each word have 12 bits. Fine. So this data only can transfer into the cache memory. Fine. So every time the size of the word will be same. If the 12 bits are the size of the main memory word, then the cache memory word will be the 12 bit only. So you can see here, when we have this data into the cache memory, again it will take 12 bits. Fine. Now in the, because we are using associative mapping, so in the associative mapping we use match logic. We have the CPU address in the argument register and we will match all the address. If the address will be matched, then the data will be selected, because we can say that now data is find out. So in the argument register we will keep CPU address. For example, we have 15-bit CPU address. What it means? Our memory size will be 2 raised power 15 main memory size, if the 15-bit address we are using here. Fine. So here we will have 2 raised to power 15 words into 12. Each word have 12 bits. Fine. Now you can see here, this is the address. So in the argument register we will have 15-bit address which is produced by the CPU. Now we have to search this particular data into the cache memory, not the main memory. So we will find out the data into the cache memory. So in the argument register we have 15-bit address, and we will check this address with the each and every address which is stored in the cache memory, because in the cache memory we will have address as well as data. Both thing we will store in the cache memory. For example, if you can see there, for example, this is a memory, and there we have data here, and here we have address in the main memory. So data and the address both will be stored in the cache memory. We will check addresses. If that address will be find out, then we will take particular data from the cache memory. In this way, the matching will be done in the associative mapping. So we don't have address of the cache here. We have only main memory addresses, and by that matching logic we will find out the particular address, and we will find out the particular data. Now these technique will have many advantages and disadvantages. What are the advantages here? Increased hit rate. When the address will match, then the hit rate will be increased, which is the better thing for the cache memory, because we should make our cache memory efficient. When hit rate will be increased, then the efficiency of the cache memory also increase. Greater flexibility. Any memory block can be stored in any cache. The most important thing here is we can store anywhere in the any block. We can store any data. There is no restriction. It should be stored in the particular address because we are storing the address and data both. Better performance. Associative mapping has higher hit rate, and which leads to better performance. Now the disadvantage. Now we have some disadvantages also there. Increased comparison time. Associative mapping requires comparing the tag bit of the search block with every line tag. higher cost and power consumption. Associative mapping require complex comparison logic which increase cost and power consumptions. More complex associative mapping is more complex than direct mapping because of the need to compare tags across of all cache lines. So we actually in the associative mapping we store the address as well as data. So the memory word size will be increased here. First this thing is there. This is again a disadvantage. And another thing, we need more hardware in the associative mapping because we use comparison logic here. So it will take more time and it will increase the cost of the system. Fine. Next, direct map. So because we have these are all disadvantage because agreement register is costly, matching logic is costly. In the case of associative mapping, we need another mapping scheme which is known as a direct mapping scheme. Okay. So what is a direct mapping scheme? You can see here in this diagram. You can see here again the CPU will generate the address of 15 bits. You can see here. Fine. Now this address is divided into two parts, 6-bit and 9 bits, which is known as a tag and index. Now the question is, what is the meaning of tag and what is the meaning of index? Now we are taking example where main memory size is at 32K into 12. What it means? We have 32 kilo number of memory words here and 12 bits of each word. So you can see address lines will be 15 and data lines will be 12 because we have 2 raised to power 15 number of words and 12 bits of each word. So data lines will be 12 bits here. Now next is an example of cache memory where we have 512 into 12 size of the cache memory, where 512 are the number of words which cache can store, and 12 bits are the size of each and every word. So address lines will be here 9 bits because it is equal to 2 raised to power 9. 512 can be written like 2 raised to power 9 and 9 bits address bit will be there, and the word size of the each word will be 12 bits again because we have here 12. So we need 12 data bits here. So now what will happen? So you can see here we need 9-bit address here. So this in this case CPU address where we have main memory address, 9 bits are allocated for index, which is the address of cache memory. You can see here this is the address of cache memory, and then when we add tag bits again in the cache memory address, then it becomes a main memory address. So you can say that CPU address is divided into tag and index. So when we have a particular CPU address, we will check index bit into the cache memory. If this index bit are matched in the cache memory, if this address we find out in the cache memory, then we will find out the particular data into the cache memory, and then we will compare the tag bits into the cache memory because these tag bits are stored in the cache memory. These all are the tag bits, and this tag bit will be stored in the cache memory because in the case of associative mapping we store all the address bits in the associative mapping. So we have a larger memory word which is not possible to store. So in this case we only store the tag bits only in the cache memory. So firstly we will find out the address index values will be find out into the address of the cache memory, then we will match the tag bits. So you can see in this example, you can see here we have tag and index bit and this is the same diagram, and you can see here in the main memory these all are the data are stored in the different addresses of the main memory. Now you can see here if the value of the tag bit is 00, so 00 we will find out here this is the 000, this is the index bit in the particular CPU address, and then we will find out the 00 tag bit. If the tag bit of the CPU address is again 00, then we can say that this data is matched and this is the required data which is CPU requesting. For you can see here the address of 0000 1220 is stored. Okay, so because the these 3 bits are 000, so we have to store this data into cache on the 000 address. So we have stored into the 00 address, and remaining 00 or the remaining bits will be stored as a tag into the cache memory. So firstly, when the CPU will generate the address of this data, then we have to check the index bit. If the index bit find out into the cache memory, then we will match the tag bits. If the tag bit match, then it means data will have been find out into the cache, and this is the hit case. And if it not find out, then we have to check into the main memory. So by this example, we can see that the disadvantage of the associative mapping will be reduced in the direct mapping, but again this direct mapping also have some disadvantage, because in this case we will have less hits, because there is a chances of more miss, and if the miss will be increased, then the efficiency of the cache will be reduced. So this is the main disadvantage of the direct mapping. Now you can see advantage are, it requires very less hardware complexity, it is very simple method of implementation, access time is very low. So these all are the main advantages, and disadvantages are cache performance unpredictable in direct mapping, handling of spatial locality is poor, use of cache space is inefficient, and the most important thing, miss are high in the direct mapping. So this is the main disadvantage of the direct mapping, which we have to reduce, because if the number of miss will be increased, then the efficiency of the cache memory will be decreased, and which is not be acceptable. So we will use next mapping scheme, which is known as a set associative mapping. That is the easy control of the direct mapping cache and the more flexible mapping of the fully associative cache. In set associative mapping cache, each cache location can have more than one pair of tag plus data items. That is, more than one pair of tag data are residing at the same location of the cache memory. If one cache is holding two pair of cache plus data item, that is called two-way set associative mapping. So you can see in the direct mapping scene, if the tag value is not match, then there will be miss, because we have for the particular index address we have more tag values. You can see here that here for the 000 we have 00 value also here, and 00, and for this 00 we have 001 tag value also there, and for this 00 we have 02 tag value also here. So but we can store only one tag value in the cache memory. So if we have address bits 01000, so 000 index bits are matched, but the tag bit will not match. In this case there will be miss. So we will reduce this shortcoming of the scheme by the help of set associative memory, where we have more, we can store more than one set values. You can see here you can set or tag value, tag values. So in this case you can see here on the 00 index value we have two tag values 01 and 02. So if the CPU will generate tag value 01, then again data will be find out, and if the tag value will be 02, then again data will be find out. So there is a less chance of the miss, and there is a more chance of the hits. So we have in the set associative mapping we have removed the disadvantage of direct mapping by the help of two tag values. We can have three tag value also, and we can have 4-way tag value also here if we using 3-way set associative or 4-way associative. In this case we are using only two tag values, that's why it is known as a 2-way set associative mapping cache memory. So it is more beneficial than direct mapping. Now again these have some advantages and disadvantages. The set associative mapping, the advantage and disadvantage of the set associative mapping are, it has highest hit rate. So in the set associative mapping we can increase the hit rate. So and when the hit rate will be increased, the cache performance also increase, and misses will be low here. So this is the main advantages of set associative mapping. Now the disadvantage of set associative mapping is it is very expensive and it is slower than the direct mapping. So these all are the three techniques we have discussed. and use for the cache mapping scheme. Thank you.